This is my old washing machine. It's now come to the end of the road. It's a Sanusi. It's done good service, but it's now only fit for parts. So I've taken the top off, and the parts I want are these solenoid valves. There's two in this machine. And another part I want is the pressure switch, the atmospheric switch. And turning the machine upside down, we want the water pump. That will be collected, and as well as the water pump we collect various Jubilee clips and anything that looks handy, but the main part of course we're after is the motor. This is the prize in this machine, and will be part of the project I'm about to describe. Okay, well here's a few of the parts I've salvaged. These water solenoids, they're lovely, I like these. Mains onto those will switch the water through the pipe, ideal for water displays, irrigation systems, and they're pretty foolproof because no electric and the water shuts off. Well, you've got two of those to every washing machine. There's the other one. So I saved the cable as well, so they're fine. This is the pressure switch I took out. Slight pressure on this as the water fills up, the switch switches and turns the pump or the water off, turns those solenoids off. If I blow down the end you can hear them switch. You hear that? I've used one of those as an automatic bilge pump on my boat. No moving parts apart from the switch inside there. You just simply have that attached to an upturned jar, and as the water rises it switches the bilge pump on, so they're handy. Save all the clips and what have you. A lot of them are in good condition. I even saved the element, because the element is okay on that machine, and it might be wanted for a boiler or soil steriliser, or somebody might want one, so that can go up onto the shelf. But the prize of all, of course, is the motor. These are beautiful motors. They're universal motors, AC/DC, so they've got a commutator and brushes and so forth. They look very complicated with multiple leads on there, but in actual fact they're dead simple. The two leads that go, these two, go to the very back. They're speed control, so you can ignore those. We use those in some circumstances, but for most operations I don't use those, so you can disconnect that. You can disregard those. You've got brushes either end of the comm where you can chase those wires. So you've got two wires for two brushes, and you've got three remaining wires usually, and that's usually the field windings with a centre tap, and you can check that out with a multimeter. So we simply put the field windings in series with our brush motor, brush connections, and we have a motor that will run on AC or DC. If we want to change direction of the motor, we simply transpose the field windings, or conversely the brush windings. Just change those over. You only need to change the one, of course, and it will reverse the direction. Now these can be run on relatively low voltages as well, and if there's enough residual I'll try it a third time, residual magnetism left in the windings, spun up, these can be generators also. So there's a few interesting parts. Normally if I take machines apart I'll even take the drum out, and the drum is quite large. It takes a bit to get out, but it's stainless steel with loads of holes in, and these make absolutely excellent garden small incinerators. They don't rust if left out, and the holes allow whatever you're burning to combust completely. Even the door glass, which is quite deep and thick, if you take the bowl out, that's actually Pyrex, and you can use that as a dog bowl or something like that. I don't chuck anything away, as you can tell. Now I'm quite amazed that machines and equipment we have nowadays actually last as long as it does. When you think it's, you know, used day in, day out, week in, back out for several years, and it's amazing they work at all. Well, this machine I've taken apart did have issues, but it did work. It pumped out fine. Now this is the pipe that goes from the pump, the sump pump, to drain the machine, and as you can see, look, it's blocked up in there, and I don't know, but it feels a bit solid there. Let's see what we'll find. I think I know what we're going to find. Just look at that. How in the world did that pump? But it did. Yeah, it's coming out now. And you wonder why these machines go wrong. It's amazing. And that's without all the calcium and hard water that gets into the machine. So it's quite a miracle these things work at all. Anyway, I've got the parts that I want. Let's chuck that away. I've got the parts that I want for this little project. I hope you find this is interesting. Okay then, whilst I've described how you can wire these up, before you rush off and do that, let me give you a big warning. We have no speed control on it, as I've described, and it will just simply rev up way beyond its intended RPM and completely destruct. It will fly apart with centrifugal forces. And as I don't want to visit you in hospital, I thought I'd better tell you. Because the motor doesn't have a load and we have no speed control in its present configuration. Hence the two wires that were referred to, which is a tachometer. And there's a circuit that you can make up and you can control the speed of these things with triacs and so forth. I'll give that on another video. Or you could put an excessive load across the brush connections, such as the element, but that's probably a kilowatt, and it's a kilowatt of wasted energy just to stop the thing from self-destructing. So here I've just connected it up as described, and I'm using 12 volts. And this battery hasn't got a lot in, it's an old leisure battery, but it's enough to run it, I think. And as you can hear, it's got quite a speed and quite a, well, I can't stop it, on just 12 volts. So we have a wonderful basis for electric bike or scooter or something. Double that voltage up again. I played around many years ago with old Lucas dynamos, but these are actually better because they've got a bearing at each end, whereas the old dynamos had a bronze bearing at one end. I think there's a video of it somewhere. Anyway, this is partly towards the project I'm working on. So what is it? Well, hang in there. I always do my level best to make my videos reasonably simple, but at the same time try and keep them interesting. But it's going to be inevitable. I'm going to get someone ask me how you wire this thing up after I've just told you. So this might help you. This is a socket that you will see on your actual motor. These are the pins sticking up you will see. And at one end you've got the little tachometer coil, which we are not using. Described that already. Here we have our main coils, and it may have a centre tap that you can check out. And at this end we've got pins that go, if you check them back, they go to our brushes. So we have effectively, we're putting mains in on one brush. It goes through the commutator, to the next brush, which is joined to one end of our coils, and then the coils go back to our supply. So they are in series. Okay, I can't put it any simpler than that. If you're still not sure, well, with the greatest respect, best avoid this project or get an electrician to sort it out for you. Now, coming back to speed controls, for my own use I use a very large SCR dimmer switch, very powerful 1 kilowatt rated dimmer switch, and this will control my washing machine motor to any speed I want in a safe manner. So that's one sort for you, but there are other circuits which are more complicated. Perhaps you might be better to view these on the web. There's loads of videos on this, and anyway, I don't want to dwell on this, so if that helps, good. If it don't, tough. Having gone to the trouble of taking a motor out of the machine, I've looked under the bench and I find I've got one, or another one. Oh, this will be for another project. It's been there for years and years and years. As you can see. But it's a real goer. And that's probably going about 14 to 16,000 RPM. So you can see what happens when they haven't really got much of a load on. Anyway, I digress. So far this video has been about washing machine motors, because that's what I've been taking apart this morning. And while I was doing that, a van drew up and a bloke said, a scrap dealer, "You want to get rid of the old machine, mate?" I said, "Yes, I've had a few bits out of it though." He said, "I don't mind," and he took it away. So, just in time. Brilliant. Right, as I said, I've been talking about washing machine motors, and I could use one of those for this project. But a more suitable motor for what I'm making, and I'm making a parts vibration cleaner, vibrating parts cleaner. You'd probably guess what I'm on about. And I've decided to use, for that, I don't need the speed. This is far more in keeping with my needs, and this is a 1/5 horsepower standard induction motor. You know, you can come across these wherever. Okay, and the speed of this is 1425 RPM, which is about right. And I will replace this pulley with a half a pulley or an eccentric weight to make the whole thing off balance and shake like hell, right? And I've mounted this on a plate with bolts, and this is the surface plate that my receptacle will be bolted to. And then the whole thing will be suspended either on springs on a baseboard. I don't know yet, I haven't got to making it yet, I'm in the process of making it, or I shall suspend it. I've got a bucket full of these things, and these are exhaust hangers for underneath the car, and this will allow the motor to jiggle like so and so. So I don't know where we're going yet. Now if you're going to use one of these, this is probably the most suitable. As I say, it's a 1/5 of a horsepower, and it's rated at continuous rating. Now most of these will probably be running for about an hour. That's important to get one like that, but these are straightforward to get hold of. And well, you can see what I've done so far. I've drilled through the framework and put some big nuts and bolts on and cranked them up. So that's as far as we got today. I've taken a short section of 1-inch bar, about 2.5 inches long, and I've drilled a hole in one end, the size of the shaft of the motor, and then with a hacksaw put a split down beyond it, and then cross drilled it, as you can see. And I find this is the safest way of attaching an eccentric weight to a shaft that I've come across. Okay, well, this is day 2. I haven't got too much done today. I had to take the missus to a doctor's appointment. Nothing serious. We had to do some shopping, but I've carried on with the project, and what I've done, I've glued and screwed and bolted a bowl like so to a plywood disc, just roughly cut on a bandsaw, and the disc is bolted to our motor, and I've mounted 4 little iron just bent over lugs bolted on, 4, so that we've got a means to suspend it. And then I've got a piece of perforated zinc or something or other, cut a strip, bent it round into a ring, and put a big Jubilee clip round here because our eccentric weight is under there, and it will save my fingers or feet. So that's all I've got done today. I was hoping to progress a bit further than this, but as I say, we had other commitments. Anyway, with a bit of luck, perhaps I'll get this done over the weekend. I won't do anything tomorrow, because tomorrow the weather looks good and the tides are right, and I'm going fishing. So that's the plan for tomorrow. So what I've got to do now, you can see how simple the whole thing is. I'm going to build just a simple wooden frame, 4 legs, that this can be suspended on, and as I said, I've got a bucket full of these things, and that should be nice and quiet and stable. Anyway, there's a bit more to this project to come, so we'll see what happens over the weekend. Today is Monday, and over the weekend I had 2 super days of fishing. I hope someday to be able to fix up a camera on the boat so you can join me, but I haven't found a way of doing that just yet. Anyway, back to this project. This is the wooden frame I made. It's very simple. You don't need plans, do you? And this is probably the simplest arrangement I thought I could come up with, and it has many advantages. I've filled the bowl with cat litter and a handful of sand just to give it a bit of bite. More on the medium I'm going to use later on in this video. But it's super quiet. I'm very pleased. Let's see if it'll do the job. I've got some pieces of metal here. I'll show you where you can see what they're like. They're nothing special, but we'll drop them in here, and we'll switch the machine on. And as I said, this is reasonably quiet. This is for inside a building, and it's perfectly stable. And we'll let this run for an hour and see what happens, and then I'll come back and give you some more information on this. Well, we've been going for about an hour now, and it appears to have done the job, but it also creates a lot of dust. So next time we'll do this outside. But I'm going to change the medium to alleviate this problem. Anyway, we'll switch it off, see what the results are like. Wow, get into focus. They look pretty good. Well, Look at those. That's quite impressive, I think. All ready for painting. Well, I think that's a success. For just 1 hour, that's worked better than I could possibly have hoped for. And it's sort of really got in there. Yeah, I'm pleased with that. Really pleased with that. The only downside is the dust. And next time, as I say, we'll do this outside. Well, I won't be using cat litter. This was just a, you know, a trial thing. This type of machine is used quite a lot in the States, where the gun people, you know, reload their cartridges and clean up the brass work, and they use all sorts of mediums, shot blasting materials and rice and crushed walnut shells and all sorts of things different people have tried, depending on what it is you want to do. And but none of it is really cheap, or next to nothing, which is the way I like to use things. A mate of mine is a commercial cockle fisherman, and he dredges, well, he don't dredge up, he sucks up vast quantities of these things on board the boat, where they're all sifted out and bagged up to go to the food processing place somewhere in King's Lynn, I believe. Anyway, they're sorted, washed and screened again, and then boiled, and of course the shells open up, and while the cockles are shaken out, they discard the shells. There's no great use or commercial use for them, and I can pick up a really large sack full for about £4, so I'm thinking this would probably be a better medium and less dusty than the cat litter, which is essentially only clay anyway, is it? So why am I going to all this problem, or you know, taking this on? Well, I've got a rather super project coming up in the very near future. I've, with a bit of luck, I've picked up a World War II really old generator, four-stroke arrangement with loads of brass and aluminium castings. Been sitting in a barn ever since, and just ripe for restoration. And I think with a bit of luck, I've got this. So hence the machine will come in very handy. If you want to see more on this project, it might be a good idea to, if you haven't already, subscribe to my channel. That way you'll be sure of getting notification to you know, additional upgrades I do on this, or appertaining to this subject. I've now got to get my thinking cap on how to crush these shells. Any ideas, folks? Other than a couple of big boulders in a cement mixer, but I haven't got one. So I'm looking at some other simple means. I haven't quite thought that one out yet, but we will. Anyway, this surely is a long enough video, so I hope it's sort of giving you an insight to what I've been doing. Thank you very much for your company. Hope to see you before too long. Bye for now.